Okay, so we have adding and subtracting. They undo each other, right? They're inverses of each other. Cubes and cubic roots are inverse functions of each other. Exponentials and logs. So we graphed exponential functions in the first three sections, right? They either increase or decrease. These are the log ones. They are reflected over the line y equals x. Because if you remember from last year, when you are trying to find your inverse, the first thing you do is you switch your x and your y and you solve for y. All right? So we need to remember when given something in exponential form, like 3 to the second equals 9. That's exponential because you're given an exponent. Okay? You're given a base, an exponent, and what it's equal to is the answer. And you need to recognize that when we talk about the inverse or the logarithmic form, that same information is presented to you just in a different format. Okay? So the logarithmic form talks about the log of the base, whatever base you're working with. Okay? In this case, our base is 3, right? When I wrote this little example here. Then it goes the answer. What is our answer in this case? 9. And what is our answer? What is it set equal to? The exponent. So the information is put in this is the same 3 pieces of information, just placed in different spots. So answer in exponential set equal to the exponent when given to you in logarithmic. So I would say the log whose base is a little subscript of 3 of what? 9 equals, exactly. So this is logarithmic, this is exponential. Does that make sense? All right. So what happens when y increases? We get really, really big. But in this case, it's when x increases that we see the difference. Okay. All right, so write this in exponential form. What would be my exponential form here? What would be my base? And then what do I need my exponent. What do I set it equal to? All right. So it's just a conversion, writing it in a different format, okay? And it should make sense, right? A cubic root of 27 is 3, all right? So the questions you ask are, what's the exponent, or what's the base? What's the exponent? What's the answer? Those 3 questions will always help you place the information in the right spot. All right, so what's my base? What's my exponent? 1/2, right? What's my answer? Right. There's my exponent right there. You're confused? So depending on the format, Mary, in log form, you're given the exponent as your final answer. Okay? In standard form, this is our answer. And our exponent is this little superscript, this little value up here. Uh-huh. Yep. Yep. All right. Write it in log form. So the log, so what's the base? Yep. This has got to be a little subscript. It's got to be written down below. All right. Now, what do I put here? 1024. And what do I put here? Right. The answer in log is the exponent. Okay. All right. Log. What do I write down here? Okay. What do I write here? What do I write out here? Yep. Are we doing good? And you know, whether or not we take 2 days on this really will depend on how well you do on the homework tonight. If you think you've got all this and we don't need to spend 2 days, then we'll go on to 11:5. All right. So these were your rules, and we've learned this. Vicki? Sure. And I'll talk you through them. Okay. So if I'm multiplying u times v, if I'm multiplying my values, then that's the same thing as adding the individual logs. That's what the rule says. So if I show multiplication and I want to expand it, which means take it out, then what I want to do is add the individual ones. Just whatever that base is, it doesn't matter. It just means if you've got the log of a base and you're showing multiplication going on, then what you want to do is you want to add them individually. Now, if I show division and I want to expand it out, then what I really need to do is I need to take the log of the numerator minus the log of the denominator. The order is really important. So you want to go numerator minus denominator. And the last one talks about raising a power to a power. This little subscript simply comes out in front, and we're going to multiply the exponent times the log of the value. Remember these from last year? Or from Algebra 2? Log of base A, u to the n. So we've got an exponent going on in this problem. We're going to take that exponent out in front and multiply it by the log. So, think about it. I said, remember, logs are just exponents, so they follow the rules of exponents. What did we do when we were multiplying our bases? 6 to the second times 6 to the third. What did we do with our exponents? Didn't we add them? That's what we're doing. What did we do when we had 6 to the third over 6 to the second? What did we do with our exponents? And that's what the rules are saying, right? What did we do when we said 6 to the second to the third? What did we do with those values? And that's what I'm showing. So we're just applying these exponent rules to log statements. All right, so we want to solve them. All right, log, I want to know, remember, this is my base. This is my what? Exponent, and this is my answer. So, it's in logarithmic form. This isn't going to be something that I can really work with. Okay, how do I get to this? I can't divide by log of 2, so sometimes we have to rewrite it. So if it's given in log form, let's rewrite it in exponent form and see if it's easier to solve. So how would I rewrite this? I would say that this is 2 to the equals. Well, this I can solve, right? Because I've isolated the x. Vicki, go ahead and turn off the heat now that it's warm. Thank you. Well, what is 2 to the 5th? Yeah. So 32 is equal to x. Thank you. Okay. All right, look at this one. Notice that there's our log base 7s on both sides. The bases are the same. It's a very good thing. All right? So when the bases are the same, let's think about it. If I said 3 to the x equals 3 to the 8th, what does x have to equal if the left side has to equal the right? Yeah, x has to equal 8. Otherwise, there's nothing else that x can be, right? So if the logs are the same, then basically that has to be, the left side has to be the right. But we have to make it look in the same format. So the problem with the right side is this 2/3. Where does that 2/3 go? If it's the exponent. So this is the same thing as saying log base 7 of n is equal to log base 7 of 8 to the 2/3. Because if you remember our rule, remember? I can take that number and it's just the exponent on our argument. So you can go one way, or you can expand it or condense it. Okay? All right, well, we know then that this really can simplify down. What is 8 to the 2/3? It's a cubic root, so it's 4. So what is the log of base 7 of n? What does n have to equal? Exactly. Making some sense? It's a manipulation, working one way or the other. So again, you want to pay attention. Log base 6, log base 6. So that means our arguments have to be the same. So what kind of an equation can I write? Right. That means 4x is equal to 60, so x is equal to, okay. We didn't do these in the first two, but we need to be really careful. We cannot have negative values in here. X cannot make our argument negative. So we have to check. And so when we do our check, wherever there's an x in our original statement, we want to look. So if 4x plus 4, that's the same thing as 4 times 15 plus 4, which is positive. In other words, sometimes you'll get more than one solution, and one of them will work and one of them won't. One of them will make your argument negative, and that's just not possible. Okay? So you need to check. And that's only when you're doing your variables. Okay, so I have log, log, and 1 log. So what I have to, if I've got log base 5 on both sides, somehow I have to condense, and so it's a log of base 5 equals a log of base 5 before I can compare my arguments. Okay? So using our rules of laws for expanding or contracting, how can I rewrite maybe even just, let's go one at a time, individually, so that it's just log base 5? Katie? Good. So we're going to say log base 5 of 4 squared minus log base 5 of 16 to the 1/4 equals log base 5 of x. Well, that's log base 5 of 16 minus log base 5 of 2 equals log base 5 of x. All right, what do I need to do now? You can't. Nope, I can't. Okay, so you're condensing. Remember, what does subtraction mean if we want to condense it? To divide, because if we're subtracting our exponents, we're dividing those bases. If we are subtracting, we are dividing. Okay? Log, right, of 16 over 2. Don't write that log statement twice. It's not the log base 5 of 16 divided by the log base 5 of 2. It's log base 5 of 16 over 2, which is log base 5 of, and now because it's a simple log on each side, we can look at our arguments and either write an equation or figure out what x is. What is x? Right. And we know by checking it, that's the only place where we have to check. If we plug in 8, it's going to be positive, so we know that that answer is viable. Okay, what makes this one different than the others? There's a missing log. There's no log. So there's no way that I can make the left side equal to the right by just looking at the arguments. Do you see that difference? But the process is still the same. We've got too many logs going on the left side. We want to have a simple log statement. So what am I going to do to simplify this out? I'm going to divide, right? I'm going to say log base 3. Now what am I going to write on top? Good. And that equals 2. Okay. So there is no way I can say 4x plus 5 over 3x minus 2x equals 2. That doesn't make sense, right? Do y'all see why that doesn't make sense? So then I have to think, if I can't work it like this, how can I change it? How would I change this? Turn it to a base and an exponent. So what's your base? What's your exponent? What am I going to set it equal to? All right. And so what I have then is 9 over 1 is equal to 4x plus 5 over 3 minus 2x. This is just a ratio, isn't it? A proportion. What am I going to do to solve for x? Okay. So I'm going to say 9 times 3 minus 2x equals 1 times 4x plus 5. 27 minus 18x equals 4x plus 5. And so I'm going to have 22x is equal to 22. So x is equal to, what do I need to do? Check. So I got to plug in 1 here, and I got to plug 1 in here. I have to make sure it's okay in each case. So I usually do a little chart. And I say, this is my value of x, and these are the places that I plug it in. And I make sure that I get a positive value. This gives me 9. This gives me 1. That means my answer is okay. If any of these values would have been negative, then I couldn't have used 1 as my solution. Does that make sense? No. You just have to check it, Vicki. That's just how I do it. Just show me the check in some manner, okay? Don't do it in your head. So x is 1 is okay. All right. Here we go. We've got this really crazy problem. Where is my unknown? In the base. Okay, so I don't know what my base is. My suggestion would be to simplify this down. 15625 to the 16. Can you even simplify that down? So this is 5. Really? Okay. Wow. Okay. So what do I do now? Because I still need to solve for my b. Change it. So what would I write if I'm going to change it? And so how do I solve for b? Yeah, I cube it. So you're just using all of these rules that we just had a test over it, right? How many sections do we have here? Okay. Okay, now we're going to graph. This is why we're taking 2 days on this. There's a lot of information here. Okay. Okay, do not graph it in logarithmic form. It's easiest to change it to an exponential. All right, so the first thing that we want to do, though, is we want to switch the x and the y. All right, we really want to say, because if we're writing it as an exponential, isn't that the inverse, right? Because it's the reciprocal or the inverse of that. So the first thing that you do when you do your inverse is you switch your x and your y. So x is equal to log base 2 of y minus 1. Because remember, we're going to have to solve for y. All right, what's my base? What's my exponent? What do I set it equal to? How do I solve for y? So 2 to the x plus 1. This 1 will not go in the exponent. Does that make sense? And I'm not going to add the 2 and the 1 because 1 has an exponent and 1 doesn't, right? Okay, this is easier. Didn't we just do this? Let's do a little XY chart. Okay, where's my asymptote? What's going to be plus 1? Is it, write me an equation. Y equals 1, right? Are we good? Growth or a decay? Growth, okay. So -1, 0, and 1. And so here we'll get 1.5, yes. Here we get 2, and here we get 3. All right, but remember, this is the inverse, isn't it? Isn't it? So for our log form, everything flips. Remember, our chart flips, doesn't it? Are you with me? Because we switched the x and the y, didn't we? So we got to switch them back. So what I want to graph is 1.5 and -1. That becomes my ordered pair, right? What's my next ordered pair? Yep, and my next one? Okay, if we're switching the x and the y, what is my asymptote really? X equals 1. Remember, we switched the x and the y. So now our asymptote is x equals 1. Do this. So x is equal to 1. So it's a vertical asymptote, right? And when x is 1.5, we're at -1. When x is 2, we're at 0. And when x is 3, we're at 1. Remember, if you look back at our first page, what do the logs look like? They go along the x-axis. They don't go along the y. Okay? So this is coming up from our asymptote and going out to la-la land. Everybody okay with this? Anybody got a question? Okay. All right, let's try the next thing. This is not a base. This should say y less than or equal to log base 3. My argument is x plus 1. For whatever reason, it stayed down there. Sure. Now, what makes this one different is the inequality, correct? So you got to think solid or dotted and recognize that you have shading. Okay? So the first thing we want to do is switch the, so we want to say x is less than or equal to log, and really, at this point, let's just make it an equality. X is equal to log base 3 of y plus 1. Because what we're trying to do really is just get the shape and get your asymptotes and get your ordered pairs. Does that make sense? Okay. So that means, what is my next step? Good. So we're going to rewrite as an exponential. And so, Mary, can you tell me what that is? Good. Okay. Vicki, what's my next step going to say? 3 to the x minus 1 equals y. Okay, Haley, what do I do now? Okay. So -1, 0, and 1. And so at -1, I'm going to get -2/3. At 0, I'm going to get, and at 1, I get. And we need to always identify the asymptote. The asymptote is at y equals what? -1. Are we good on this? All right. So now we're going to do the log form. Okay. So what we're really wanting to look at was what we were given, which is y less than or equal to log base 3 of x plus 1. All right. What's my xy chart going to say? Good. Yep. Good. And Rachel, what's my asymptote? Good. All right. So now with all this information, keep in mind, solid or dotted? Okay, because the inequality actually has the equal sign. So -2/3, -1, 0, 0, 2, 1, solid. And you know, greater than is above, less than is below. Where are we shading in this inequality? Great. Making sense? Okay. All right. You want to go up to the board and do these two? Go up to the board. Let's see how you do with these.